welcome to Elizabeth Walsh. Elizabeth is joining us from the US today. Thank you for joining us today, Liz. We are speaking about integrated pest management, or IPM, for today's topic. Would you like to give us a quick intro? I understand you've been beekeeping north of the Rockies in Alberta, and now you're based in Louisiana. What's some of the work you've been doing in your extensive bee research career?
Oh, thank you so much for having me. It's my pleasure to be here and it's my pleasure to chat. So I began beekeeping almost 18 years ago now, in a northern area of the US, a state called Wisconsin. And so I had all four seasons, and growing up, I began keeping bees while I was in high school. So I learned the importance of Varroa management quite quickly. Um, and then from there, I went to my undergraduate studies at a small college called Ripon College in Wisconsin. And that was where I realized that working with bees in a research sense was a possibility. And so that quickly captured my heart, my interest. And so I went straight into a PhD program at Texas A&M University with Juliana Rangel. And that's where I began to learn more about the opportunity costs of the things I had done to control Varroa. So my dissertation was focused on assessing queen health when queens were reared in beeswax that contained field relevant levels of miticides. And I use miticides and acaricides interchangeably, but the pesticides that we as beekeepers use to control Varroa. Um, and so I did that work in Texas at the southern part of the US. And then from there, once I graduated with my doctorate, I leapfrogged up to northern Canada, where I did some really fantastic and interesting disease ecology work with Steve Purnall. And so I got to learn other things and see diseases that most beekeepers absolutely dread the possibility of ever seeing. Um, there, I got to work in what I think is the only lab on the continent, actually, that does field experiments with American foul brood, for instance. Um, Here, I'm in Baton Rouge, Louisiana, the capital of the state. And I'm in the southern portion of the US again. And just like most areas in this country, we have so many colonies that we cannot do disease work that we could up there in a more remote area. So now
Okay.
I'm in my dream job with the United States Department of Agriculture, where I'm a research entomologist doing honeybee health work at the Honeybee Breeding Genetics and Physiology Unit.
Fabulous. Very interesting career so far with some really interesting people that you've worked with. That's so cool. Um, so I wanted to just move, I suppose, into our first real query about the topic today. Could you explain to us what is IPM and why beekeepers need to know what that means?
Absolutely. So, integrated pest management, or IPM, is a system of managing pest species with livestock or with any population of concern. And so, integrated pest management was something that historically came about from entomologists and ecologists after they realized the detrimental effects that DDT and overuse of DDT were having downstream. So, not just on humans and human health, but on so many other species as well. And so, this idea of overusing pesticides and perhaps being on what's called the pesticide treadmill or the chemical treadmill began to come about along with the dawning realization that with great power comes great responsibility. And so we have this phenomenal tool in chemicals, but we really need to use them responsibly in an integrated pest management framework. Now, in IPM, we have what we refer to as the pyramid. And the pyramid has a foundational layer of cultural pest management strategies. These are things that do not incorporate chemicals, but they're things that you, as a producer or a grower, can just incorporate into your operation in a daily sense. And they might require some energy or economic input or temporal input to begin. So, for instance, buying bees that are resistant to Varroa or cattle that are resistant to a particular disease or pest as well. Those would be examples of cultural controls at that basal foundational layer of the pyramid. And then as you rise up to different levels on the pyramid, you do that because you're monitoring your pest population levels and you're seeing that the controls that you've been using maybe aren't quite cutting it. You've still got some stress, your pest population levels may still be rising, and you want to keep those below what's called an economic injury threshold. An economic injury threshold is where your pest population rises high enough that it causes damage to your livestock in such a way that you, the grower or producer, have an economic loss from that damage. So
yeah, like a negative impact to you. Yeah.
Exactly. So ideally, the pest population is suppressed, and you've got this kind of economic neutrality almost, where it's like, oh, okay, we're sort of straddling this line between the costs we have to control this pest and keep it suppressed versus the loss or damage of our colonies for beekeepers. And so by monitoring your pest population carefully, you might realize, oh, the cultural controls that I have just aren't cutting it. I really need to step up my game a little bit. And perhaps that may be the impetus to rise to that next layer of the pyramid, which would be mechanical controls. These would be things like trapping, inducing brood breaks, things like that. You can continue to rise up the pyramid as needed and as your sampling informs you as needed. And so in some populations and its systems, the next step would perhaps be biocontrol methods, but we don't really have effective biocontrol agents for Varroa at this time. So the next highest level for us, if we're thinking about Varroa control in our honeybee colonies, is really the chemical step, which is the tip top of the pyramid. And many people will split this tippy top of the pyramid into two different portions: soft chemicals and hard chemicals. Some people use wording like natural chemicals and unnatural chemicals or synthetic chemicals. But I kind of just prefer hard and soft chemicals just because there seems to be a little bit less human judgment in there. And so essentially, in a nutshell, you're going up the pyramid as the sampling of your pest informs you. You need to be going to greater and greater measures to suppress populations below an economic injury level. So if you're monitoring carefully and closely, you never have to go to drastic measures like, oh my goodness, I'm going from doing nothing to using hard chemical because I just realized this was a problem. Oh my goodness. So ideally, you're always incorporating some cheaper, safer methods of control and incorporating more as needed. And I hope that makes sense.
Yes. And I suppose all of that does make sense. I think the cornerstone of that IPM method and the strategies that people employ, would I be right in saying that the cornerstone of that is monitoring?
Yes,
yeah.
Absolutely.
So monitoring now, if you're a beekeeper in an area where we know Varroa exists, at least if you were in the state of New South Wales, because there's a chance you should be looking out for Varroa. But all the states in Australia should be acutely aware that monitoring is the cornerstone. And once beekeepers start to live with Varroa, monitoring is that management tool that helps us to understand whether our treatments are necessary and then whether our treatments are then working for us. And we can make a judgment once we sort of know how many mites are in that 300B sample of our alcohol wash or our sugar shake or our soapy water wash. Could you give us a little bit of, in terms of some examples of cultural controls and some of the mechanical tools and just the pros and cons of those that you think are there, in your opinion and your experience?
Of course. So I think that there's always pros and cons with everything. And as you alluded to, everyone has their own perspective. And just as an aside, I think personally that's one of the beautiful things about integrated pest management is that you have this wonderful toolkit of things that are available that Australian beekeepers can learn vicariously, which is wonderful. And so you can pick and choose what is the best integrated pest management strategy as a whole for you and your operation, which is wonderful.
Yeah, yeah. Take a little
Yeah.
bit from this and a little bit from that, but essentially, yeah, we can make those decisions on our own.
Yeah.
Sort of set of ways we want to make our bees work for us, whether that's a commercial enterprise or even that recreational space. Yeah.
Yeah. I think that's
So
really setting Australian beekeepers up for success. And the
yeah,
educational materials can only help and not hurt that process. So to kind of go into answering your actual question, so examples of cultural controls. Well, as a scientist at the Honeybee Breeding Genetics and Physiology Unit, I have to mention Varroa resistant bees, which do exist. They were very hard bred for. And so it takes a long time of concerted breeding to have a program that's effective like that. In our case, it took 10 to 20 years to really reliably get resistant lines. And as the Resilient Bee Project is already identified, it's possible that bees could be imported, but you might be importing some other things along with that that make it not so worthwhile, such as viruses, that Varroa vector that aren't present in Australia at this time. And so you've got these pros and cons, right? It takes so much time and effort to have an intense breeding program like that. But at the same time, uh, you could be incorporating other things into your breeding process unexpectedly as well. So, as a case study, my unit is the one that imported Russian honeybees into the US. And we did
okay.
this very, very carefully. The US government in a different area of the USDA, we're quite good at making sure that we did things safely and with a common sense approach. So these bees were isolated on an island in the Gulf for many years. I think it was more than 6 years before it was like, all right, we've demonstrated that we're not taking in anything else that we don't want to. We've
Yeah.
also demonstrated that they're quite effective. And given the numbers of losses that have accrued in the last 6 years, we really do think that now is a good time to take them to the mainland. And so I think it is worth noting that, as with everything, there is no cure all. So the Russian honeybees did not become widely spread in terms of every beekeeper keeps Russian honeybees now, and they're all Varroa resistant. But what it means is that at that time, some work had shown that if beekeepers were not doing a treatment program, within 2 years, the colony would die of Varroa. And
Okay.
so the Russian honeybees gave a little bit more freedom to beekeepers and a little bit more room to experiment with different treatment techniques that worked for them. And so that was really a boon and a case study of a good example of a
Yeah.
cultural control. But as we work our way up the pyramid to mechanical controls, two examples of those really would be drone trapping or queen caging. So both of these rely on a pretty hardy knowledge of honeybee and varroa biology for the beekeeper to do them well and for them to work.
Yeah. A real
Um,
skill set that probably not a lot of just regular Joe beekeepers would have in spades. So take a bit of practice for people to make sure they get it right. And if they just get it wrong,
yeah, it
bit
depends on the
damaging.
control technique, right? Yeah, because the thing with drone trapping, so for viewers that may not be terribly familiar, drone trapping is where the beekeeper puts in a frame of drone comb, that cell diameter that queens lay drone eggs into. And then when the drones are pupating and capped, Varroa preferentially parasitize drone pupa over worker pupa because the differences in development time are more in tune with the Varroa biology and reproductive biology than the worker timeline is for the Varroa mites. And so Varroa are amazing in terms of being able to sense, mostly through olfaction, we think, if a larva is male or female. And they have that instinctive, all right, this is the one I need to enter into. And so beekeepers can use this very effectively to their advantage by removing frames of drone comb that are capped. And when they do that effectively, we've seen in studies that beekeepers can be removing as much as 80% of the Varroa in their colonies, which is amazing for a non-pesticide based control technique. But the flip side is that if you're not on your calendar, you may leave that drone comb for too long. And if the drones emerge, then you've accidentally built a Varroa factory rather than a Varroa trap.
Problem. Yeah. Yeah. Or,
so,
I mean, also what comes to mind is potentially doing this at the wrong time, or doing it and then have a real issue in the environment that follows that removal. And so, you know, and it doesn't work for all beekeepers. And as we said, there's like that flexibility for people to pick and choose from that IPM pyramid of what might work. So, yeah, so some people could get the timing really wrong, especially not removing them. That really worries me. I just, that's a lot of Varroa, isn't it? If you don't get them out.
It can be. Yeah, it can be. It can also be, I think, part of the reason that approach appeals to me so much is that as much as 80% without pesticides is incredible. But it is very much not a beginner control technique, to be sure. And the other thing, that other technique in this mechanical control step that I mentioned was queen trapping.
Yeah.
And you do this, again, the beekeeper has to have a good knowledge of the biology involved. So you do this long enough to induce a brood break. And for me, this is quite a risky move because the levels of queen supersedure can be quite high because you're messing with the colony's sense of queen rightness. And so this comes not just from queen pheromones, but from the combination of queen pheromones and brood pheromones. So there is the absence of brood pheromone in the colony because you've induced a brood break. That's good. That's what you want. But you're inducing this sense of queenlessness, perhaps, into the colony, and the queen may be superseded in light of that.
You'd have to have your work cut out for you. You get in there and knock down cells regularly.
Yeah, you do.
Doing that?
Yes, very much so. And I think one of the things that works really well for American beekeepers is aggressively splitting. So I think we'll talk a little bit about honeybee and Varroa populations and their patterns in rising later. But if you can time some aggressive splitting, then you're inducing a brood break anyway, whether you really mean to or not.
Yeah.
And so if you're doing this according to your standard practices anyway, then that can also be a good control technique. You might leave them queenless a little bit longer than you may have before, or you may have that introductory period a little bit longer than you did traditionally. But you can, there is so much room for creativity in integrated pest management. You can incorporate things like this into practices that you do already if you're mindful about it and you're keeping up on the biology. So again, I'm biased as a biologist, but knowledge can only help. So
yeah. And I guess we've heard from other speakers as well about, choosing a number of colonies to do this to, so that you don't lose everything you've got, but rather that you've got a little bit of room to practice some of these techniques to figure out what works in your area and what works for your beekeeping style. So you've done our two. I think that's really good. I just
That
I
tippy
thought I
top of
might,
the pyramid
yeah,
remains.
yeah, we'll get
Yeah,
to that. We'll get to
yeah,
that. So even in this stage where we're looking at doing preventative measures, mechanical or cultural measures, why is it so important? Can you tell us why, why is monitoring that cornerstone? And you've been monitoring at these stages, at the lower levels of the pyramid. Um,
yeah,
and how, when we implement some of these techniques, what does it mean for us when we're doing monitoring to understand the colony phases, and what to expect in washes at certain times of
yeah.
the year?
Yeah. So I think I follow that, and hopefully my response will thoroughly answer. But imagine if you will, this traditional nectar flow where bees are slowly going into this growth period where nectar becomes abundant, the resources in the colony are becoming more numerous, and the population is rising, the brood is rising. All of these things are going up.
Yeah.
Varroa are also going up because whenever brood is increasing in the colony, so are Varroa. And so that's all fine and dandy. Things are staying on the level. So
Yeah, they're going
the if
together.
you they're going together. Yes, exactly. And so if you started with Varroa at fairly acceptable levels, they're staying there while the colony is growing so much so fast. However, all good things come to an end, including nectar flows. And so as those nectar flows go down, your bees tend to stop, slow down, potentially halt brood rearing altogether as their environment changes and the resources that they're getting and using to support the colony changes. And so now we have our honeybee population going down. However, the Varroa population is plateauing. It's staying where it is.
It's
Varroa
hanging
mites
around.
can live exactly. Varroa mites can live longer than individual honeybees. And so, although the Varroa are not going up, the infestation rate, which we calculate as a percentage, where it's the percent of phoretic bees on the adult honeybees in a sample, that percentage is going up because although the Varroa are staying the same, the honeybee population numbers are going down. And so this is where problems really begin to come to a head. And so beekeepers that are particularly in touch with the nectar flows can foresee this coming, and they'll be monitoring to keep an eye out for when the Varroa and honeybee populations start to problematically diverge.
Yeah.
But if you're not really keeping an eye on things, you can really have a rough surprise. And so that's where it's like, okay, we've exceeded our economic injury threshold, which here in the US we have at 3% phoretic mites in a bee sample. So it's like, oh, I went from 0.5% to 4%. Oh my gosh.
So
So
is that
that's
is that
where
3% every time you monitor throughout, from January to December, or is that 3% at a certain time of the year?
depends on who you talk to.
Oh, okay.
And so that's really where things get a little bit dicey. So nationally, we say 3% on the whole, but really, realistically, you're very much right. And that percentage depends on what time of the year it is. And
Okay.
part of that depends on just the biology of the colony, but some of it depends on our economics too. So
Mm,
just like in your region, we have various miticides and acaricides that we can use at different times of the year, depending on what's going on. And so sometimes we may be constrained by weather. Some acaricides are temperature dependent. You can only safely use them when the temperature is below a certain amount. And
yeah.
others you can use at different temperatures, but you are absolutely not okay to use if you have supers on or honey that you're going to take for human consumption. And so it's good to monitor, and things become, I would say, if a beekeeper here reaches 3%, you really have to step up your non-pesticide based control techniques no matter what time of the year it is. But if it is a time of the year when you can treat with a miticide or a acaricide and you're at 3%, that's the time to do it in the US. And so It's
Can I
also
just
worth
ask
noting,
quickly, are you going to talk
yeah.
about viruses in that
Ooh, I
percentage?
can. I can. I was actually first going to talk about how, just briefly mention that during my 18 years as a beekeeper, these percentages have changed as we've
Okay.
learned more.
Okay.
So during my time, they went from 6% to 5% to 3%. And if
Okay.
I had been beekeeping
That's
2 years
interesting.
earlier, I would have seen them go from 8% to 3%. So
Okay.
it just depends. And it also is highly dependent regionally. So here in the southern US, we have no natural brood break during
Hmm.
our winters. So the Varroa are being reared year round. Whereas in my home region, there's an induced brood break by the weather. And so there's that
Yeah.
hard stop in brood rearing for several months, and it changes the game. And so here, in the spring, you come out with very high Varroa infestation levels in this region because you've been rearing Varroa all winter. Whereas in my area I grew up in, that's not the case. You have them highest in the fall. So
Yeah.
it is important to monitor so that you know what's normal and so that you
Yeah.
can see if something isn't normal. Oh my gosh, I need to be taking drastic measures.
Yeah. Which
And
which
part
makes
of
it
that,
hard. It because
oh yeah,
beekeepers here are like, tell me what to do. Tell me exactly what I need to do. And there's just so many variables in terms of what those beekeepers actually do to run their bees. And then there are just so many climatic variables that we just cannot provide that. And we haven't been living with it for long enough either. It does make
well,
it
and I
really
think
hard and
yeah, I think
complicated.
it's something so human to be like, oh my gosh, I see a problem. Just tell me what I need to do to fix it, please.
Yeah.
And I really do think that Australian beekeepers are set up for success. I really do genuinely feel that way because you have the opportunity to learn vicariously from
Mm,
everywhere else. And
yeah.
so the good thing is that you guys are harnessing that in such a wonderful sense. You're scientists, you're extensionists, you're doing a fantastic job both educating Australian beekeepers with the options that are available and also trying to see what works where and embarking on the
Yeah.
discovery of that so much sooner than we did in the US. So
Oh,
don't
that's
give
nice.
up. Take heart, take heart. But to go back to what you were saying about viruses,
Mm,
oh, that's a very, yeah, that's quite a fraught topic, isn't it?
it
So
is.
here in the US, we have DWVA and DWVB. We also have a host of other primarily Varroa vectored viruses, and they're just here now. They're everywhere.
Yeah.
And it's quite the toss up because, of course, there's a very strong association with Varroa and these viruses, but it means that, and I see this mistake in sort of expert novices, if that makes sense.
Okay.
So, beekeepers that are newer, but that do kind of know the ropes. And so they have well, one described himself as having enough knowledge to be dangerous. And what this meant in his particular
Humble.
instance, if we can use him as an example, what this meant was that he neglected sampling over the summer. For he got caught up as one does, but he did sample as soon as he could. And he realized, oh my gosh, things have gotten way too high. They shouldn't be this high right now. And so he took drastic measures, which for him entailed the use of hard chemicals.
Yep.
Um, and he continued to sample and he saw his Varroa levels go down quite appreciably. And he breathed a sigh of relief and was like, so we're good to go. And then his
Yeah.
colonies started dying left and right. And eventually he realized that it was because he did send samples for testing and he realized that he had successfully taken care of the Varroa, but the viruses that the Varroa vectored can't be, we don't have an antiviral for Varroa vectored viruses. So it's not like you can just pretend that never happened.
Yeah.
Very sadly and tragically.
Damage has
Um,
been done. Is that,
exactly.
yeah.
And so I
How
kind of
sad.
refer, Oh, it's so sad. I kind of refer to those colonies as zombie colonies, which my students always laugh at. But I really do feel like you're the walking dead. You don't know you're dead yet, but for whatever reason, whether it's you were the control group in an experiment, you were for whatever reason, we
Yeah.
let your Varroa levels get quite high. And we'll
And
treat
we
you
watch you
now,
suffer the
but
consequences of that.
yeah, the hard
Terrible.
life as a scientist where it's like, oh no, I'm so sorry, but it's for science, I promise.
And it's
Um,
interesting too. Like I think we've had a similar, I mean, I don't know this
yeah,
story exactly, but we've had a similar person in Australia that has done their alcohol wash and found four mites in their alcohol wash in December, which is summer. And
yeah,
then our rules and our expectation was a minimum of 16-week alcohol washes. And the minimum was really stressed to people, but we encouraging them to do more. But this person might have just gone back to that 16-week. And by the time they re-washed them 16 weeks later, the numbers were really high, over
yeah.
150.
Oh my
And
gosh.
rather than immediately treated, but it didn't bring them down enough. And I think that's an example of you know accidental behaviour that it didn't pay off. And I don't know that that colony is going to do really that well. It may recover. Watch this space because it's only very recent that that was sort of revisited, and the alcohol wash after the treatment had come out 16 weeks later was still at a treatment threshold number.
Yeah.
So
Well,
even though we don't have viruses, essentially the ones, deformed wing virus, for example, there's still a risk that the damage is being done with the highest numbers of Varroa like that. That's quite a
well,
sad
it's oh,
situation.
it's
So
so
we're
sad.
saying monitor, like if you find it and it's not at a threshold, keep monitoring every 3 to 4 weeks to make sure that
Yeah,
you are doing justice to those colonies to make sure you're keeping those
yeah.
levels as low as you can. Yeah.
Well, and two, something that doesn't get talked about, at least in the US, as much as I'd like it to be, would be that the just like with humans, if you're immunocompromised or if you're stressed, you may become immunocompromised. There's all these things that can suppress your immune system. And in honeybees, we have sort of a similar situation here where a colony can be stressed by multiple things. And it may be that if they were stressed with one thing alone, they would be fine.
Yeah.
But having
The
more things
compound.
it doesn't necessarily mean, oh, the sum of A and B is C. It may be, oh, the sum of A and B may be F. It may be something very different because there may be some sort of synergistic effect there. Um, my disease ecology work really showed me that, where it was like, oh man, here we are, we're doing work with one disease in particular, but we're finding that really the results we were
Everything's creeping in.
expecting correlates with Varroa counts and not with this thing that we thought that it would. And
Right.
so these things all interact with each other. And so nothing's as clear cut as you think it is, right? And
Mm.
so there's quite a lot of joy in doing science in such a complicated and elegant system. But for beekeepers, it means, okay, I watch beekeepers get quite stressed where it's like, oh my gosh, so I thought I was just having to monitor varroa mites, but instead, at certain times of the year, I also should be monitoring for nosema in addition to varroa
Yeah.
mites or this other chalk brood in addition to varroa mites. It's like, oh, these things make it worse. If I have a yard that is prone to chalk brood, maybe my economic threshold for varroa is lower than it is in the rest of my
Yeah.
operation.
Yeah. So that was
And
one of my
so
questions, is pest and disease awareness in IPM important? Other pests and
it
diseases. So yes,
It
obviously.
absolutely is. Yeah, it
Yeah.
means that you've got a little bit less room for error. You have some less grace, if you will. And particularly some really fascinating work out of Tom Seeley and Dennis Van Engelsdorp's labs have really shown that things travel in a bee yard and even outside of apiaries where colonies that are crashing or doing poorly for whatever reason, those maladies spread. And they spread through robbing as colonies go, a weak one, a free grocery stop.
Yeah.
And so they take Varroa with them back to their home colonies, but they can also take other diseases too. And so it really means, to me, it stresses the importance of another cultural control, which is the idea of a quarantine yard. So if you've got an operation that's big enough to need a separate yard to have, okay, let's put all the sick ones in one spot and we can maybe monitor those twice as often as the ones that are fine. But those are the ones we have to look out for. Those are the ones we've identified as having problems. So that's really quite a good practice if you can, because you're removing the disease carrier from the healthy ones, but you're also able to devote more resources if you know the location of those colonies that need a boost and need extra attention and intervention.
It reminds me of, cattle properties and sheep properties when you think something's wrong there, bring that one in and you isolate them just in case it's something that is going to impact the rest of your herd or the rest of your livestock.
Exactly.
It's a little bit tricky with bees in terms of our requirements in Australia to manage AFB. So it can be problematic doing that. You're not meant to move colonies that have got AFB, but it could be other things. It could be that care they need to bring them back from chalkbrood, to bring them back, maybe not move them entirely out of the apiary, but that's
you can
a great
even set up a corner.
Yeah, and I think people do that. They do that. They shift their sort of odd-looking situations to the edge, and they might manage that as a separate load, like load within a load or something like that.
Makes sense.
Yeah, I haven't prepared you for this question, but I wanted to ask biological controls.
Oh yeah.
What? No one seems to have any. So do we just skip that in beekeeping for IPM? How do we?
No, it has been investigated. It has.
Okay.
It's just that the ones that have been investigated haven't been particularly worth pursuing in the field.
There's some fungal investigations. Yeah.
There's also there are other predatory mites that prey on other mites, and those got quite a bit of attention for a while as well. And so the problem with that, as research groups in Canada as well as at Texas A&M have shown, is that in the lab in vitro, if you put different kinds of mites in the tube, this particularly plausible predatory mite, which is used as a biological control in various greenhouse systems, called Stratiolaelaps scimatus. Sorry, it's quite the mouthful.
Taking your word for it.
Yeah. So if you put them in a tube with Varroa mites, they'll kill the Varroa mites. But when you start introducing them into the colonies, it seems like they also predate on honeybee eggs and young larvae. And so it's like, well, that was a possibility as a biological control agent for Varroa mites. But it's been, because the Varroa biology is so in tune with honeybee biology, it's so difficult to get to a tiny little mite under a capped honeybee pupal cell without damaging the honeybee pupa.
Yeah.
So it's quite a difficult road.
And I've heard about pseudoscorpions as well, but I mean, they're like little ground dwellers, and you'd need them to just happen to fall off a bee and down where those pseudoscorpions might want to capture them and eat them. So it's a challenge. I'm sure that science is going to provide this avenue a little bit more in the future, because there's so many dependent things that haven't been able to be investigated fully because we don't have enough research funding for it, or we don't have the exact scientific ways of proving the methodologies or whatever it might be.
Yeah. All I can really do to assure you at this point is that the interest scientifically is there. There have been investigations, and you're exactly right, there will continue to be. as well.
Yeah.
It's
Yeah.
just that, like with anything, you want to make sure as a scientist that you're um, really making the best recommendation, something that can only help, might help, can't hurt at the very,
Mm.
very least, right? So just from a practical standpoint,
Yeah.
those
We're be
things
patient.
that, yeah, that barrier hasn't quite been met yet. So,
Okay. Um, so IPM and beekeeper intervention is really important. Can you tell us about the change in the colony's population through the year,
oh,
and the
yeah.
number of mites that people find in washes, and the accuracy of, I guess, knowing that number you've got in a wash is accurate and is a good representation of what you need to do next?
Yeah, absolutely. So we talked before a little bit about how honeybee populations and Varroa populations were mirrored during part of the year, during buildup, but not during let down from a nectar flow, right? Um, and so during these changing periods, it's really important for beekeepers to both be cognizant of that and to keep the biology in mind while continuing to monitor.
So I wanted to move on to resistance, mites
Oh,
being
yeah.
resistant. How does it occur, and what are the consequences?
Indeed. Well, you really can learn vicariously from the US on this one. So resistance in anything can occur to almost anything if the duration of exposure and the severity of exposure are high over a long, like consistent over a long period of time. And so that's true with pretty much any pest. And I'm softening my words here, but that's what causes resistance.
Mm-hmm.
That can happen to anything for any pest. And here in the US, we have just a delve down history lane here so that your viewers can vicariously learn.
Yeah.
Um, my good friend Gary Oreskovic was a Wisconsin beekeeper, and by good friend I mean I met him several times. And so he in the US we really have switched to a migratory pollination service based beekeeping system where the majority of the money is gotten through pollination contracts rather than in proceeds from honey, for instance. And so Mr. Oreskovic had a migratory route from southern US and Florida to Wisconsin and the northern US. And when right after one of those runs, he found Varroa mites and he just saw them visually and was like, oh my gosh, what is this? And so he went through his entire operation. He found Varroa in 19 colonies. He set them all on fire because that's what he was told to do. And before he did that, he sent samples in to the local USDA office at the time in Madison, Wisconsin, to confirm his find. They confirmed his find the next month, and 3 days later, in the U.S., what's called an emergent ag exemption, Section 18 exemption, if you care to know, um, was put on the books so that beekeepers could use a miticide that had worked for other mites in other systems. Okay. And so you can imagine in 3 days, you can imagine that sort of panic in the beekeeping community that would cause this to happen. This was in 1987. And so this unknown pest, oh my gosh, how do we deal with it? We know that we treat pests that freak us out, like AFB, by burning the colony. That's what we're doing. Like hopefully he got it here in Wisconsin and not in Florida and trucked it all the way up. But within that happened in September and October of that year. By January, another 10 states had confirmed Varroa finds. And really the only tool in people's toolkits was a miticide, a synthetic, a hard chemical miticide. And so
They did what anybody would
It's
do, is protect
exactly.
their livelihoods.
Exactly. They had some very hard decisions to make, and they had so little data to make those decisions on. And so at the at the end of the day, what happened is resistance, as you may have had a gleaning that this was leading up to.
Yeah.
Um, so what happened was beekeepers began treating heavily, treating prophylactically, out of this sense of panic and concern and ignorance, because not through any fault of their own, but because we just didn't have the knowledge yet.
Yeah.
And so they set up the perfect storm to breed resistance in Varroa mites to the product they were using. Um,
Yeah,
and
they
we
just kept
didn't
using
really.
it over and over. Every time they needed something to knock down mites, they just put the same chemical in, which
Well,
is,
and not just that, but they didn't really have good monitoring methods either. So a
yeah,
lot of this use was prophylactic. And because it was using a different product, the
and
dosage wasn't terribly dialed in either.
prophylactic
So,
means treating before you actually know if you've got it, just for listeners
yeah.
that are going, what is that big word? Because
Yeah, it
I think
means
it's
treating as a
important.
preventative.
Yeah.
So treating as a preventative, not a good thing to do for any
With
pesticide.
with really quite harsh chemicals that's not even there. And
Yeah.
that costs you money.
Oh
That would
yeah.
be a very big no to do
Yeah.
that. You know, it's going to
Well,
cost
and
lots.
exactly. Well, and not just in terms of money to buy the treatments, but also in terms of time to apply and to have your crews apply.
Yeah,
And also like just stress, like, oh my goodness, you don't even know what your levels are because you don't have good monitoring methods. And so, of course, this got us on the chemical treadmill where that miticide became ineffective. So we had another Section 18 emergency ag exemption. We jumped on the next miticide. We used that until it caused problems, and that happened lickety split, because people were like, well, if one dose works well, then two must work great. And so that was really unfortunate. And when that miticide started failing, they combined it with the old one to really drive that resistance home. And so now you have our current situation in the US, which led to my dissertation work, where our beeswax is universally contaminated by these two initial miticides that were so overused and abused. Um, and so it really is
still
a tragic,
40 years later.
still, still.
Interesting.
And so, and the half-life is so long. For one of those products, it's about 7 years. And so our levels are still so high that in my dissertation work with field relevant levels in the beeswax that I reared those queens in, there were negative effects on the queen health. And
Wow.
so what this really hammered home quite well to me is the value of integrated pest management. Australian beekeepers don't need to go down this road. You can live
Yeah.
vicariously. You know
Yeah.
to avoid breeding for resistance in your varroa mites. You can use a variety of different control methods, not just within the pyramid as a whole, but also through different modes of action. And when you do choose to use pesticides, which is a legitimate choice if your levels indicate you need it or will be very soon approaching the need for
Yeah.
it, you can use, I mean, Australia has several different products that can be used. They have different modes of action. They're a combination of hard and soft chemicals. You, as a beekeeper, have a wonderful toolkit where you can use different things. So you're avoiding relying on one pesticide or on any single control method. So
Yeah.
I really do mean it when I say I do think Australian beekeepers are set up for success.
That feels great to hear you say that because, yeah, the backstory that you just gave is it's a missing piece into why we're saying IPM, rotate chemicals. Best practice is this now. Just let's all, think about the consequences of our actions. Yeah. Oh, that's
Well, it's
crazy.
it's so natural to want the single cure, right?
Yep.
And
Yep.
so we really do. If some must be good, then more must be better. And it's a very
Yeah.
very human instinct. But yeah, we really are in a rough place because of the decisions that were made so long ago. And so that means that the decisions we're making now will also have an impact that many years down the line. And so, really, it might feel like the things that you decide personally in your own operation don't make a difference, but they do and they can. So,
Yeah.
they can do that for good as well as bad.
Yeah. Yeah. So with resistance, we sort of understand and we're warned in the labeling of all of the products that are available at the moment. We're warned about the risk of synthetic treatments mites becoming resistant to them. But what about the organic acaricides? Can we, and I know that they're not being used for as long a time frame as the synthetics have been used in the US. And I think the driver of the use of organics in the US has predominantly been um, synthetic resistance. So they're searching for other options. They're finally
Yeah.
on the IPM kind of in a more proactive way. And I think there's such a short time frame that other parts of the world have been using organics. And I'm making an assumption. Tell me if I'm wrong and if I'm making a generalization that's really incorrect. But um, Australian beekeepers actually, we have some organics available. Can bees, can Varroa become resistant to organic acaricides?
Sadly, yes. So, just like with anything, it's the duration of exposure and severity exposure over the length of time that those pressures are there. So, there's a lot of reasons, including the ones that you said, why organic acaricides or miticides have not been used as stringently as synthetic or hard chemicals in the US. And because of that, in addition to several other things, means that Varroa have not developed a resistance to the organic acids and soft chemicals that we use here. Part of that also is the chemistry of these compounds. The softer chemicals are much less likely to be lipophilic, which means fat loving, essentially, if you break down the prefix
Yep.
and the suffix. But beeswax binds, the beeswax matrix really binds well to some chemical groups. And so, including many of the synthetic miticide groups. And so what that means is that even when you take out the delivery method, that a lot of that compound may still have bound to the beeswax matrix and may still be present in the comb. And so what
Yep.
that means is the Varroa are still receiving this low level of pressure, breeding pressure, from the presence of this miticide long after you've taken it out of the colony. And so that's why our beeswax is so contaminated now. And the organic or softer chemicals are much less likely to sort of linger in the colony that way.
Yeah. And so the studies haven't really existed long enough.
Yeah.
That'd be fair to say
Well,
to say that organics are yet to be proven to be like mites are yet to be proven to be resistant to the organics that are being used.
so I think for a variety of reasons, it's going to take Varroa much longer to develop any sort of resistance and for humans to detect that to
Yeah.
a
Okay.
organic compound. And I hope that makes sense. But I think that because of their nature, as things that don't linger in the colony as long, and as things that, at least in the US, are still not relied upon as much as harder chemicals, I think
Okay.
we're much less likely to see resistance develop to those at the same frequency. I'm not. I think it would take a concerted effort
Yeah.
for to breed Varroa that were resistant to organic chemicals to the extent that we have bred them to be resistant to harder chemicals. So I am using scientifically dodgy language. I'm trying. You never say never, but
Yeah.
uh,
I guess that's what I was
it's
sort of aiming
yeah,
for is that it's technically speaking,
Technically,
it's
it's possible,
impossible.
but
Yeah.
it's not as probable, to be sure.
Okay. Yep.
Yeah.
Yep. So could you give us an example of a case study that has utilized, IPM, maybe two types of IPM tools
Yeah.
that you can share with
Uh,
us?
Absolutely. So in addition to bringing Russian honey, I'm looking out over the rails of bees we have outside my window. Uh, and so my unit did, our claim to fame is not simply importing Russian honeybees. We have done breeding programs here that have heavily utilized artificial insemination after being carefully selected from commercial operations, colonies that showed great promise as pollinating colonies on the migration circuit, but also colonies that consistently had quite low levels of Varroa. Um, and so we isolated those and conducted this incredible breeding effort for quite some time. And now we have what we call poll line bees, which stands for pollination line bees,
Okay.
that have exhibited quite a high degree of Varroa resistance. And those are what we typically just use at the unit, although we do a lot of stock comparisons and we do have lots of other honeybee stocks present as well. Um, some poll-line bees don't need any sort of intervention to control Varroa, but some do. And so there is always variation in any population. And so we might pair just these resistant bees with a soft chemical. We might do drone trapping if someone has inclination to do so. We aggressively split quite frequently. And so these are combinations of all of these different techniques that work for us.
That's great. Yeah. And I think it's that implementation and experimenting with something just to have a go and to see what works in the bees you do have, because there's a lot of variation, but also in that climatic variation and the impact, the pressures you're putting on them, to produce or to build up numbers. It's an interesting space, I think. I've got
Oh
bees
yeah,
back
it's
where I live, and looking at them now in a different light completely to my original experience with honeybees, now that they have Varroa, is a really different headspace. To think,
oh
oh,
yeah.
what can we do here? And looking at that range of options and whether it might work this year, but it might not work next year, or
Yeah.
the impact of something might not be a time, as an option to do if you've got no time to manage.
Yeah. Yeah. Well,
Um,
and it's like, yeah, that learning curve was quite that learning curve stymied me a little bit when I was running my own operation personally. It took me quite a while to figure out, oh, okay, so when my colonies are in single deeps, like drone trapping works great. I am on it. It works so great. But once I put that second box on, I become real bad. Like the season is heating up. I have less time. I'm not keeping as good records.
mm.
This is past Liz. Present Liz keeps much better records all the time now. But that was a learning curve for me. It was like, oh, okay, drone trapping when the nectar is becoming more abundant works quite well for me until I need to have a second box. And then I can't do it. Then I need to stop because then I switched to doing more harm than good. So
Okay.
learning those patterns about yourself as well um, is something to pay attention to, and being realistic about what you find.
Yeah. Yeah. So you've mentioned in the publication, the Resilient Beekeeping in the Face of Varroa publication, that beekeepers should work out the economics of their businesses now in Australia.
Yeah.
Just have a think about it.
Yeah.
Can you give us a simple outline of a basic IPM schedule for a subtropical climate? We have many different climates, but we just
Yeah.
sort of pick one. If we pick subtropical,
Yeah.
like a honey producer, there's
Yeah. So I can try to elaborate some about that. And like you said, these are all going to be incredibly individualized. But for instance, if I was a subtropical commercial beekeeper, and I primarily made my money on honey production or varietal honey production, then that would change my integrated pest management strategy. Because like we said before, there are some miticides that are off the table for me then. So during any honey producing year, I have to be incredibly careful what I'm doing to manage my mites. Because if I have to resort to something at the top of the pyramid, because otherwise I'll lose my colony to Varroa, then I've lost that honey that was on the colony because I've introduced this miticide that's not safe to have on the colony when my supers are on it.
Yeah.
And so you have this really difficult emotionally math where it's like, okay, what is the cost of the colony? What is the cost of Varroa treatment? What is the cost of Varroa treatment if I lose the honey? What is the value of that colony if it's honey producing versus if it's not? What are
Yeah.
These get really complicated really fast, and they're all so highly individualized. So here, for instance, it's migratory in a sense that I don't believe it is on Australia. And so there's goods and bads with that. But so what that means is if I was an Australian beekeeper who did more what I am calling migratory work, where I'm moving colonies,
Yeah.
then it's like, well, all right, maybe I need to look at these costs and maybe I need to assign different thresholds to colonies that I take versus what I leave. So if
Yeah.
I'm taking colonies and I'm paying in the petrol to take them, that's quite an investment in and of itself. You don't want to have to get there and then have to treat and not just pay for that treatment to happen in that place that is not your home base, but also why are you migrating? Is it going to cost you that varietal honey? Is it going to maybe not impact you if it's more for a pollination contract? Like these are the sort of mathematics that I really would recommend that beekeepers do sooner rather than later. It's always easier to do these before you're emotionally involved, where it's like,
Yeah.
oh my
Yeah.
goodness, I'm
Think
looking at
about,
disaster.
yeah, thinking about the year that you've got ahead of you, I suppose, let's say a year,
Yeah,
where you know you're going to look for this honey flow, that maybe there's 3 or 4 or 5 honey flows you're expecting in the next financial, like the next 12 months, and making a consideration that if you get Varroa in between now and that any of those times, where your monitoring is going to be happening, how far away that is. We do lots and lots of migratory beekeeping in Australia. A lot of our honey production is 75% of the honey produced in Australia comes from our state forests. And that's a lot. You know, people don't always live there. They're moving around a great deal. And it is an important factor in terms of keeping up your monitoring for a start. Even if you don't have Varroa, we should be doing that. We should be making sure we know if we do or we don't. And then I guess assuming you do at some point, and making that decision of what are the options? Do I forego a honey crop? Am I willing to forego a honey crop? Well, does that mean you want to monitor a little bit more to make sure that you get it, you pick it up rather than do a wash and find 100 mites because you didn't monitor earlier? There's a
Well,
lot
and
of
I don't mean
considerations.
exactly. Well, and I don't mean to be all doom and gloom either. It's not just like plan out your reactions ahead of time. It can also be plan out your prevention ahead of time too.
Yeah, okay.
And so it's like, all right, what is the risk I'm taking moving colonies to an area that may have other people that they may pick up Varroa, like what you alluded to, but also like, okay, let me make a concerted effort to monitor everything. I am only sending the colonies that have 0 mites. Like those are the ones that I'm going to send because I don't want to these ones that have some small numbers of mites, I need to keep an eye on. those ones, those can be sent. The risk of needing to change my IPM strategies to incorporate a drastic measure like introducing a miticide, like those, the risk is lower because they have 0% in found infestation. These ones, all right, I'm going to step up my IPM methods that I am doing and continue to monitor, and these I'm keeping here for now. So it can be a preventative tool too. It's just, it does make things easier if you plan out the best case scenario, the worst case scenario.
Yeah.
If you do all of that ahead of time, it can only help and can't hurt.
Yeah, yeah. Look, we're a pretty vivacious bunch of people in Australia. All of our agricultural contributors are a tough bunch who really want the best for their livestock, and beekeepers are absolutely no different. So I'm hoping that this series, especially this one on IPM, this particular interview, has provided them with some insight that is useful and that keeps them on that path forward to be able to make decisions that are right for them. This is probably our last question, so I'm really glad we got to this. And I'm asking this of all of our participants. What advice do you have for Australian beekeepers? We're all learning and we're adapting in these new challenging phases. How can we stay on course?
Well, I'm really letting my biases fly, but I think that you guys are doing my advice already preemptively because you're presumably listening to this random educational product preemptively. That's wonderful. I think that increasing knowledge and planning out what scenarios, what responses you're going to do in what scenarios, that sort of education you can't put a value on. And so listening to random experts on the internet is probably quite a good place to start. And so that sort of harnessing of vicarious learning is really, really to Australia's advantage here right now. And it's so neat to see you guys doing that and in such capable hands. The research and extension work that's already being done is really phenomenal and heartening for me to see across the globe. So,
well, that's fabulous.
Continue.
Thank you.
Continue at it.
We've got some great people doing some great work. Our transition to management project and program is underway. There's lots of workshops coming across the country that will help us learn and help us develop our skills and change our practices, including learning about IPM as well. So look, I'm on behalf of everybody who's listened in after this is posted, we really are grateful and appreciative of your contributing to this and the book as well. So thank you, Elizabeth Walsh, for participating today.
It's definitely my pleasure. Knowledge is power, and it's wonderful to be able to share that.